Well,
or that was the foxhole one.
That was the foxhole
Yeah.
one.
All right, we're gonna try to figure this thing out tonight. We got a little feedback problem. Martin, I saw when you did your head and you wiped your head like this, the feedback went woo woo, went up and down, and when you came down like that by your earphones, it changed a little bit. Let's just see if this can come from Martin. We're gonna do an experiment here. Martin, I got you on camera here now. All right, Martin, do something. Rub your head, touch your ear. Yeah.
You got to rub your belly and touch your head.
That's right.
Oh, I can't do both of them.
Or maybe buggy bumpers.
Y'all may not be hearing it, but Martin, when you wiggle all that around, I get a real high squeal back here. I'm not sure what it is, but we'll tell you what. Just if you will, just put yours on mute for just a second, and then we'll live with it. We'll live with it the rest of the time.
Put your single sideband filter on. Get rid of the high pitch.
It's probably something to do with SWR, I would imagine.
You know, maybe his microphone's rubbing on
All
his
right,
shirt.
all right, all right. Let me get this thing back on the road here, guys. So, okay. Hey, today is October 27th, I do believe, and you're listening to and watching Amateur Radio Roundtable on W5KUB. If you're listening on shortwave out there on 6160 on WBCQ out of Monticello, Maine, we'd love to hear from you. Send us an email to tom@w5kub.com, tom@w5kub.com. Send us an email. Let us know where you are, how you heard the station, and so forth. And let me just also tell you that if you have internet access right now, you can go to our website and join the show and see the video. You can just go to w5kub.com and click on live chat and video. And I understand from the chat room it's saying that on our site it's not working and it's redirecting you to YouTube, but you'll get there. All right. Seems like there's been a lot of changes going on in the last couple weeks here with YouTube, and we're going to get them straightened out, I promise. Hey, we got Martin back with us tonight. He's been out a while. We're so happy to have Martin back. Let's see, what else we got going tonight? Oh, the 40-meter net went really well tonight. We only had one guy on 40 meters get on there and talk about how he didn't like the show and it's just a bunch of old people and blah, 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 blah. Of course, I ignored him on there and acted like I didn't hear him. So if you're watching tonight, I did hear you. All right. So let's see. Let's go around the hall here, the room, and see who we got. KSC, Alan's up first. Hey, Alan, how you doing, man?
Hey, hanging in there. Completed another orbit around the sun this weekend. So starting on my 59th. How did that happen?
Oh, okay.
But, doing good tonight. We didn't get any comments on the Facebook post asking for questions that folks have about SWR. So we'll just kind of have a bit of a open discussion, maybe dispel some of the myths about SWR and talk about, I got a whole list of topics here we can kind of cover, but no formal program, but hopefully just some informative chat.
Okay, well, cool, man. We're looking forward to your segment here in a little while.
All right.
Katie, you there?
I am here. And so is today your actual birthday, Alan?
No, Saturday was number 58. So now we're 2 days into the 59th.
To your new,
Oh,
well,
man.
happy birthday.
Thank you.
And to do a favor to all of the world that's watching, I won't sing to you.
You know,
Okay.
I was busy trying to check something here, and I didn't catch the part about the birthday. I heard you talking about another trip around the sun.
Yeah, another trip.
And I'm thinking, okay, has Alan launched a balloon? What's going on over there? So I wasn't paying attention, but happy birthday, man. Happy birthday.
Thank you.
A balloon around the sun. Yeah.
Yeah, around the sun. Around the sun. That's right. Oh, okay. Glenn, I'm gonna put you on mute. Katie, you look all warmed up there. Is it cold out there?
It actually was 32 tonight when I was driving home from yoga, so it warmed up quite a bit. Yesterday, when I woke up, the weather was a high of 22 and a low of -3, and it was -3 in the morning when I left for work.
Gee.
So it got up. It did get up to about 20 yesterday. So winter is definitely here. We've got quite a bit of snow on the ground. So.
Yeah. Hey, I saw. Yeah, I wasn't following this, but I saw yesterday ice storm hits Texas and Oklahoma out there.
Yikes! Yeah,
Wow.
that's crazy. Up
But,
here we expect that. Down there, not so much.
Yeah,
But,
yeah.
so yeah, and we're just Dwayne's been talking to a local ham recently, and he's newly reinvigorated in the hobby, and he's been a ham for quite some time, but kind of took about 5 years off, and they've been talking a lot. He's going to put up some new antennas, just bought himself a couple new radios, and really excited to get involved. We're going to, start getting back to work on getting a club up and running around here. So excited about that. And, Dwayne wants to, get bylaws and organizational charts and all the engineering type things going. I'm like, no, let's just get people together and just do something. We can worry about the other stuff later. Let's just start gathering people and doing hammy stuff. So hopefully we can do that. It's tough right now, and we're having quite a community spread of COVID up here. So we may just kind of do some planning right now, and then hopefully maybe try for at least a gathering and a meeting room somewhere along the way in the near future, just to start talking about some ideas and helping people get on the air.
Well, all right. I didn't think there was enough hams out there to have a club.
We actually have quite a few in our county, and we've been in a test session, and Mom, I think, is watching tonight. Hi, Mom. We've done quite a few test sessions, and we have, how many hams do we have in the county now? We have at least 35 hams in our county.
Oh, that's good.
And so that's pretty good for our little area, little neck of the woods. So yeah,
that's
so
good.
Looking forward to. We've been talking about it for a while, and it just kind of can't seem to get out of our own way. But having a ham in the area who is just excited to be a ham again and get on the air, it's like, all right, we gotta strike while the iron's hot here and get off our butts and do something.
All right. Well, hey, let's jump over to Martin real quick. Hey, Martin, how you doing, Martin? You're gonna have to unmute your mic. Where'd Martin go? There's Martin. There he is.
I think Katie's right. I think my microphone is rubbing on my shirt. But I'm doing fine. Our employees have come back to work. We're starting to get parts, and we're back in production. We're doing real well.
Well, that's good. I want to come down and see you guys again, but I understand that y'all are all locked in different rooms and wearing masks, and I'll just have to wait till it gets better.
Well, I think the only one locked up is me in my room.
Well, hey, don't get out if you don't have to, Martin. So you're doing good. All right. Hey, I sent my tuner down there and Kara Hank. Hank said put his name on it. So tell Hank tomorrow he's got a package coming.
Okay. I told him it was coming, so he's looking for it.
Yeah, I'll probably FedEx it down tomorrow. Okay, boy. I need to get me 3 or 4 of those kilowatt tuners you got. That would, put one on every antenna I got. That'd be cool, man. All right. Oh, Glen Popiel, KW5GP. Glenn, how you doing?
Well, good, and I'm prepared just in case you do mute me. I still have my notepad.
Okay, cool.
busting our tail on the book. As I was saying earlier before we started, I'm pretty much on paid leave right now while they figure out if I've got a job or not. And I'm taking advantage of that time and busting my tail finishing up the book. I'm cranking out about a half a chapter a day, which means we're looking at about 2 to 3 weeks of it being finished and completely turned in. So it's rolling right along. And one quick thing, you had Martin's call wrong when you popped it up there. It's not,
oh man, it's FLU.
it's FLU, not FLA.
Man, I've done that once before. I apologize, Martin. In fact, when I did that, Martin. When I did that, when I did that today, I had in my mind specifically, I've messed this call up before, and I'm not going to mess it up this time. I really thought that. My
he does
goodness.
that with my name
goodness.
all the time.
Well,
so
let me tell you, and it's because Martin hadn't been on here in a while. I didn't even recognize him. I didn't even recognize the guy. He's been away so long.
Well, just remember funny looking underwears.
That's right. That's right. We'll fix that. Oh man, gee.
Oh God, we're not going to be able to unsee that one, are we?
Oh man. All right.
Oh, we got Katie Scorton. This is good.
All right. All right. Let me get the show back on the rails here. All right. So, Rich, let's go to Rich up in New Jersey. I think he's the last one here on the list.
Hi there.
Hey.
I'm getting by here without, without too much difficulty at the moment. We've also, like most other parts of the country, have a growing community spread of the virus again. We've been doing very well here and started reopening lots of things, and now all the numbers are going in the wrong direction again. So we're going to see what's going to happen.
Well, I heard you say all you guys are working from home now. You kind of going to make that a permanent thing.
At least semi-permanent. We've decided to go virtual. When we had to go virtual for 3 months earlier this year, we realized that it worked pretty well, and we decided to do it on a semi-permanent basis starting the fall. And so we are working in the cloud, so to speak, and it's working out well.
Well, that's good that you can still at least work and get the word out and do ham radio and all that. You know, it could be worse, I guess. Mm-hmm. All right, well, let's just get started here, Katie. Why don't you and Rich talk about CQ?
It seems like just last week or so we were talking
It almost was. It really was almost last week.
I think it was too. I'm still laughing because John, one of our regulars, KC7GRI, just mentioned in the chat. He goes, "It was on the rails before." And Glenn popped in and says, "When I'm here, keeping it on the rails is a full-time task." And I said, "That is the truth." So if you guys aren't here on the chat room while you're watching, you definitely got to log in because we have some fun over there as well. But anyway, so moving on to the fun of the really cool magazine, CQ Magazine. Welcoming back, obviously, Rich Moses and W2VU, who is the editor-in-chief and Superman extraordinaire for CQ Amateur Radio Magazine. And it's the end of the month already. We were just talking recently about the other issue because our timeline got goofed up, but it's already October 27th, so that means it's time to talk about the November issue. So welcome back, Rich. It's good to have you with us.
Good to be here again. And it has only been 2 weeks, so
yeah.
But it's fun. Now, I don't remember if 2 weeks ago I promoted the calendar or not, but it's in. It's ready to go.
Yeah,
if I did, I'm promoting it again.
Excellent.
Gets you through 15 months with really cool broad spectrum look at what ham radio is about, different kinds of people, different kinds of activities, and it's been one of my favorite things. So, November issue of CQ is really cool as always. We've got kind of in honor of the combination of having the WPX CW contest results and November being the month for the CQ Worldwide CW contest. I hope a lot of people got on and had fun last weekend in the CQ Worldwide SSB contest. I got on, had a lot of noise level here, and ended up, Martin, you will enjoy this.
Martin just had to put his glasses on to check it all out.
Oh, yeah, that's great. Are you on me?
Richard?
I accidentally hit mute when I moved the computer over, but that filter, that audio filter, was a real lifesaver. It pulled a lot of signals out of the noise. It was a really bad noise levels here, and I was able to hear them with a little bit of twiddling and tweaking and turning and tuning.
Great.
I've had that for a long time, and it's still plugging along. So,
Well,
but
that's
back to the
great.
magazine. Our lead feature this month is about hybrid multi-op contesting at W7RN. It's the Comstock Memorial Station, run by K5RC and company. The Comstock name comes from being located on the Comstock Lode in Nevada. You can look that up. It's where the silver or gold rush was, I forget, but lots of history there as well. So we had featured earlier in the year fully remote contesting as something that was going on, multi-op contesting as a way to deal with travel restrictions and group restrictions. And Tom has a slightly different take on this with what he's calling hybrid multi-op contesting. There's one person who is physically at the station, taking care of the radios, making sure everything is working okay, and then the other operators are all remote. So it's a interesting combination of remote and local operating, and he's got a great article there about how it works. We've got the results of the WPX CW contest, which going along with the rest of the year so far has seen record numbers of logs submitted. Lots of people are not traveling places, they're at home, so they're getting on the radio. And ham radio has been a really great tool for keeping people in touch with each other when they're otherwise might be trying to get my watch to stop beeping here, but I can't do it. Oh well. Sorry about that. Eric Nichols, KL7AJ, has an article on a November surprise, which you have to read it to see what the surprise is. But I'll give you a hint. It has to do with contesting. We got a really fascinating article by K1YOW, Joe Zikovich, on winter sporadic E-like propagation on 6 meters. And you may be familiar with 6 meter minor sporadic E peak in the winter and wonder why he's calling it sporadic E-like. And that's basically what the article is about, why he his research on it has suggesting that it's not actual sporadic E, but other things at play. So it's a very, very interesting article. And if you're interested in the nuts and bolts and technology and science behind E-skip propagation, you'll find it very, very interesting. Speaking of antennas, and which I wasn't, and technology, we went back to some old technology for our CQ Classics this month. We did 2 articles on grid dip oscillators, which anyone who's been around for more than about 25 years will be probably familiar with. CQ introduced them to the general ham public back in the 1940s, and they became a staple in most well-equipped ham shacks for many, many decades, as long as people were still using tubes to have a grid to dip.
I did a video on that a few years ago. It's been a pretty popular video, and I still have the Heathkit grid dip meter that I built probably in the late 70s.
Well, that's great. I was looking around for one to take a picture of to go with this. I know I have one somewhere because the pictures we had are from the old article, so they're old grid dip meters, but I couldn't find it. I know it's here someplace. Of course, now I'll find it when I don't need it anymore. But
Wait, we still sell a grid dip meter.
okay, great. That's good to know. So I'll have to at least get a.
I just posted my tutorial video in the chat room.
So, moving on to our columns, we've got our emergency communications column is on the ARRL's renewed focus on MCOM and 60-meter interoperability with federal stations. Several instances in the past month or so of using 60 meters for contacts between hams and federal stations, both in drill and in real life for storms and wildfires. So very interesting stuff there. We also introduced the new ARRL's new Director of Emergency Management, and that's something that they've added for the first time. We have a new emergency communications editor as of the December issue. Stan Broadway, N8BHL, who is the section emergency coordinator for Ohio, and he's written for us a couple of times before. He's got lots of great experience, both professionally and as an amateur in emergency communications. And one of the articles that he wrote for us back 4 years ago was about what was it called? Five events, 4 cities, 1 week. The state emergency management agency was coordinating 2 large conferences at the Republican National Convention and 1 other activity in 4 different cities in Ohio, all going on in the same week. And ham radio was an integral part of that, and Stan was the person who was coordinating it all on the state level. So he's done a lot of really, really interesting stuff, and it's going to be very interesting to share his experience and expertise with us in the pages of CQ going forward. So his first column is going to be in the December issue. In our listening post column on shortwave listening, WBCQ made the headline this month with its purchase of WHRI, another shortwave broadcaster. So congratulations to WBCQ on expanding its universe there. Joe Eisenberg, K0NEB and Kit Building is writing about the Morserino 32, really cool little Morse code oscillator kit.
It's a great name, Morse.
Yeah. We've got our homing in column by K0OV on putting a fox hunting beam on your vehicle and still driving safely. Digital connection column this month is called the Propagation Whisperer, and it's all about Whisper, the weak signal propagation reporter software, and the great things you can do with that. DX editor Bob Schenk, N200, writes a personal column this month on DXing and how he got started. And he's had quite an accomplished DX life, and very, very interesting stuff there. And in our contesting column, our new contesting editor, Tim Schappa, N3Q, I can't even read this, QE, there we go. I haven't gotten used to his call yet. N3QE has a very interesting look at CW spectrum usage and code speed in the CQ Worldwide CW contest. What parts of the band which bands tend to be most used, and the influence of code speed. Very, very interesting stuff. So that's a look at some of the highlights of the November issue of CQ. And you can sign up for it on our website for either print or digital subscription at www.cq-amateur-radio.com. And while you're there, buy a calendar.
All right,
Sounds
cool,
good,
man.
Tom.
Well,
Well, it sounds like another issue full of fun stuff, and I got to get caught up on my reading. I saw John said he just finished reading the October issue just before the show started tonight, and I think I'm behind by at least a couple of issues. So I got some reading to do to catch up, but this sounds like a fun issue as always. So I look forward to it. Thank you for joining us again, and we'll look forward to having you back hopefully at the end of November to talk about December's issue. I can't believe we're getting so close to the end of the year, but
I know.
again,
We're coming up to the end of our 75th anniversary year.
I know, it's amazing. 75 years. So it's been an amazing year of great issues and stories. And I know just the chat rooms always, and everybody who's watching are just big fans of CQ, and always look forward to having you on to talk about what's coming next. So
well,
thank you so much.
like Katie said, you know, you'll be here before we know it. I mean, time flies, and this is like my dental appointment, you know. My dentist sends me this thing every 6 months, you know, for teeth cleaning. I swear it must be 3 months. I'm gonna have to start checking a calendar.
Well, now I hope you're not comparing reading CQ to going to the dentist.
Yeah,
I'm just saying, you know, I don't know, man. You know, we're supposed to see you about once a month, you know, and it seems like it's been every 2 weeks lately.
That's funny.
hey, but that's
All
a
right,
good thing.
Thank you.
Chris just says 75 years of 2020. Now that one you got, Chris. That is-
Oh, man.
Ain't that the truth?
Thank
But
you.
see, I don't really
Thank you.
need a calendar. I just go to Walmart and see what decorations they have and add
Yeah.
3 months.
Exactly.
Oh,
They got
man.
Christmas out now, so
Oh,
All right. Thank you, Rich, so much for being with us again on just seemed
My
like
pleasure,
a short
and,
interval, man. A short interval. Anyway, always glad to have you, man. Thank you. Hey, let's in just a second we're going to jump into Tech Tips with Alan. We're going to talk about SWR in a minute, and that's going to be fun, I think. We'll be back.
Hey, a quick funny thing.
Yeah.
Dwayne is actually over there on the radio right now working on FTA, and he's working Bob N200.
Oh, is he? Is he? All right.
It just shows me, I'm like, oh, you're kidding me. That's
Tell him
funny.
to tell Bob I said hi.
Yeah, he's on FT8, forget it.
Oh.
yeah, not going to happen on FT8.
All right, time
All right.
for commercial.
All right. We'll see you guys. We'll be back in a minute. Let's talk about a brand new ICOM radio. Get out and be active with ICOM's new IC705. The IC705 is your perfect QRP companion as you have base station features and functionality at the tip of your fingers in a portable package. It covers HF through 70 centimeters. This compact rig weighs in at just over 2 pounds with RF direct sampling for most of the HF bands and IF sampling for frequencies above 25 megahertz. It also has a large 4.3-inch color touchscreen with live band scope and waterfall. You get 5 watts with the BP272 and 10 watts with a 13.8 volt DC power supply. It has a micro USB connector, Bluetooth, and WLAN. Integrated GPS with antenna and a GPS logger. It has a micro SD card slot, and the HM243 speaker microphone comes standard. The perfect accessory for the IC705 is the LC192 backpack. It has a special compartment for your IC705 and room for all your accessories. The IC705 now has received FCC certification, and we expect product to be shipping to dealers by the end of September. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
Just about. I'm just
All
across the
right,
state
we
line.
are back, and hey, we did have an open mic. You know how open
Uh-oh.
mic gets you sometimes?
Good
You-
thing
you
I didn't
guys-
use any bad words.
You guys talking there in the background, actually, we had an open mic, and some of the people were actually hearing you. So I'm glad you are all,
Well behaved.
well behaved. That's a good point here. All right. All right, hey, let's jump into Tech Tips with Alan. Hey, Alan, how you doing, man? And what do you got for us tonight? What are we going to talk about?
Oh, good to hear you. Good to see you. Tech Tips. I feel like we need like a little logo that flies in, says Tech Tips or something. So, but I don't know. But yeah, so I thought no formal program tonight, but I thought we'd chat about a topic that probably crosses just about every ham's mind at one point or another, and with a ton of myths around it and things like that, and that's SWR. So I thought we'd just talk about what it is, what it isn't, what to worry about, what not to worry about, how you measure it, how you control it, and that type of thing. So, as we go along here, I encourage us to be a bit of an open discussion amongst us, and then if anybody in the chat room's got questions, certainly be sure to post them, and maybe some folks can keep an eye on the chat room here because I might not see the questions as they scroll by. But so really, what SWR is stands for standing wave ratio. And it's something that happens on a feed line when the load at the end of the feed line does not match the feed line impedance. So most of us are using 50 ohm coax to lead up to an antenna, for example, or a 50 ohm coax to lead into an amplifier from a transmitter. And if the load at the far end of that feed line doesn't match the impedance of the coax, in this case 50 ohms, or maybe 450 ohm window line going out to an antenna or something like that, you'll actually get a reflection of the RF signal. And that reflection, as it comes back, you can almost think of it as a wave going down in one direction. And when it reflects off the other end, you get a wave going in the opposite direction. And because they're the same frequency, because they're the same signal, but going in opposite directions, when they add to each other, they're going to get areas where it adds constructively and areas along the line where it adds destructively or subtracts from each other. So you get this kind of standing wave that happens along the line. In fact, I've got an interesting graphic. Let me see if I pop it up here. Let me just go, let's see if I can share here. You got to let me share there, Tom.
Okay, we can do that.
Yeah, sorry, I didn't give you a fair warning that I wanted to share.
Yeah, we can do that. There we go.
So just an interesting little graphic to kind of illustrate that. Let me pop up this guy here. And this is just from the wiki page on SWR. But if you can see this moving graphic, you can see like this blue wave moving, essentially left to right. And let's assume that that's hitting a load and then reflecting and going back, and that's the red wave going the other way. And at any point in time, if you add those voltages up, you get essentially what you see in this black wave that's kind of wiggling up and down, but is not moving in either direction. Okay, and that's essentially the standing wave. And what'll happen from an RF standpoint is you wind up with instead of a constant power envelope across the line, the amount of RF voltage that you see across the line when you've got an SWR, it'll essentially vary. And the ratio of the peak voltage to the trough of that envelope is the standing wave ratio. And that's essentially what an SWR meter measures. That's what it is. So what does it really mean? So what it means is that, all of the signal that is being sent out to the load, like the antenna, is not necessarily being absorbed by and therefore transmitted by that antenna, and you'll have some energy reflecting back. And there's a lot of myths out there about, well, hey, if I can't get my SWR down below 1.5 to 1, I'm not going to get out, or things like that. And there's a lot of these kind of myths that I wanted to kind of dispel here a little bit. And there's a lot of really good references out there. There was a really good paper that I remember reading about 14 years ago. I'll see if I can find a link to it. But this is if I can get a good picture out of this on here. It was done by a guy named Darren. Let me see, Darren Walraven, K5DVW. It was published in QST, I believe. Yeah, QST November 2006. Understanding SWR by Example. really good, just a couple of page article that talks about things like that.
Yeah, Alan, I have it, I had it pulled up and you can
There
see
you
it
go.
right here. There's the whole article if you want to
Yep.
check it out a little later.
Yeah. So yeah, if you got the link, we'll post that up on the. Just go to the ARRL website. You can go to. It's in the technical archives there. But even things like people worry about. I got to have my SWR down. I got about 1.6 to 1. Oh, it's growing. I got to do something about it. And the reality is that you can almost consider any SWR that is 2 to 1 or lower to be pretty close to perfect. And if you say 2 to 1, that's horrible. That's bad. But it really isn't. A 2 to 1 SWR means you're reflecting 11% of your power from the load. That's not even measurable in many cases, right? So don't really sweat it too much, and don't sweat the fact that your SWR is 2 to 1 or 1.8 to 1, and I got to do something to get it down to 1 to 1. It really literally is not that important. And if you have a tuner or a transmatch, a tuner in your radio, or you're using an antenna tuner or a transmatch, and you're using that to reduce the SWR that your transmitter sees, people think, well, that's just cheating, and it really isn't. It literally is just doing providing what we call a conjugate match. So the transmitter sees the match that it wants to see, and then a conjugate match is provided at the other end of the feed line, so that the energy that's reflected back from the antenna essentially gets re-reflected back towards the antenna again. And the only thing you really lose is any losses that are in the antenna tuner itself, in terms of resistive losses in the antenna tuner components, and losses in the feed line. Okay. And at HF, in most cases, unless you've got 400 feet long feed lines of RG58 running at 10 meters or something like that, you generally don't even have to worry too much about feed line and the antenna and the feed line losses. And especially if you're running, like 450 ohm line is extremely low loss. You can run very high SWR on those lines and essentially still have nearly all of your power going to the antenna. In fact, that's the antenna I run here, is a 130-foot dipole fed with 450 ohm ladder line into a good low loss tuner. And I run that on everything from 75 meters up to 10 meters, and very effectively. Well, considering that it's not up in the most advantageous place, because I live on a postage stamp lot here in New Jersey. But other than that, all my power is getting to the antenna. So that's I say people sometimes I think just spend too much time worrying about SWR when you really have to. One of the myths that you often hear is that, well, if I got a high SWR, I just need to adjust my feed line length and get it down. But the reality is that SWR is not dependent upon feed line length. Okay, and we can go through the math to do that. We can take a look at the effects on a Smith chart and things like that. But it really comes down to the fact that SWR does not depend on feed line length. Now, people might say, well, I added 5 feet to my coax and I measured an SWR that was different. Now, that's usually due to the fact that maybe whatever device you're using to measure the SWR doesn't like working in a non-50 ohm environment, which is what will happen when you have SWR, and will misread the cues. Or you might have some common mode line currents and things like that might be affecting the cues. But the reality is that SWR does not depend on feed line length. The only thing that can happen is if you have a very lossy line, the SWR can read artificially low compared to what it really is, because the reflected energy, or the power going out to the antenna, and therefore the reflected power coming back, can get attenuated by the feed line length, so that the reflected power you measure at the transmitter looks lower than it really is, because of the loss. So a lossy feed line can actually make your SWR look better than it really is. But that's simply just due to loss characteristics and not due to anything really having to do with length other than the loss per unit length. Another myth that you often hear is that high SWR causes feed line radiation. And again, that's simply not true. Feed line radiation is due to things like common mode currents, meaning currents in both conductors that are going in the same direction, not opposite directions. Okay. And that's basically what happens in an antenna, right? The antenna, you've got currents going in one direction, and that's what's giving rise to the radiation. A feed line, you've got equal but opposite currents, so they cancel themselves out, so it doesn't cause feed line radiation. Even if you have high SWR, those currents are equal but opposite. So unless you've got some signal coupling onto an antenna, or you've got imbalance in those things because of asymmetry in the way you've got the feed line with respect to the antenna, high SWR does not cause feed line radiation. Similarly, another myth you hear is that high SWR can cause RF radio frequency interference. You get interference in my television or my telephone. It's all because I've got high SWR. Again, that's not true either. Typically, because you're not radiating off the line, just the fact that you've got an antenna close to those devices is likely what's causing that RFI. Again, people will sweat 2-to-1 SWR, and I think that's mainly because a lot of modern transceivers will start folding back power if the SWR climbs above 2-to-1. Okay, and that's just to minimize power dissipation in the finals of these transmitters. But that isn't necessarily going to cause, isn't really a problem. And again, using a little bit of a transmatch to correct for that is a perfectly valid and thing to do, and it's something that's done, commercially in commercial RF systems all the time. Okay, there's really no magic about about having that perfect 1-to-1 SWR. And again, another comment often that you hear is that all that reflected power is lost. The reality is the reflected power isn't that high. For a 2-to-1 SWR, it's 11% of your power. But if you've got a properly adjusted transmatch or antenna tuner at even at the transmitter site, that reflected energy is reflected back towards the antenna again. And the only thing you're really losing is losses in the feed line or the tuner itself. Another popular myth is that an antenna tuner actually reduces SWR on the line, and that's not true at all. Right? The SWR on the line is due purely to the mismatch of the load or antenna to the feed line. No matter what you do with the transmatch at the transmitter end, it doesn't change the fact that the SWR still exists on the line, and that's still okay. And all that you've got to really think about when you're doing that is that if you're using an inline SWR meter to measure the effect of your transmatch, you want that, obviously, that meter to be between your transmitter and the tuner input, not between the tuner output and the antenna, because you're not going to be changing the SWR on that. You're only going to be changing the SWR or the impedance seen by the transmitter, and that's what you're measuring with that. Ideally, it's always a good idea if you can to have the tuner located at the antenna itself, because that way you can make the impedance looking into the tuner and the tuner or the tune circuit and the antenna to be close to a match to the 50 ohm feed line or whatever feed line you're using, and therefore minimize any of those mismatch losses. But and like remote mounted tuners are a good idea for that type of a thing, and typically more important the higher you go in frequency. For us on the HF bands and things like that, it's really not so bad. Let's see what other things I had noted here. One of the things I wanted to mention was, what about these kind of magic feed line lengths? I want my feed line length to be, an odd multiple of quarter wavelength, or an even multiple of quarter wavelengths, or half wavelength long, and things like that. So let's talk about what, and people say, well, you really want to feed it with a multiple half wavelength, because that's going to be the best. Anything other than that, you're going to mess up with the SWR, and that's, again, not true. So, but there is something magic about quarter wavelength lines and half wavelength lines. So a half wavelength line, or a line that is a even multiple of half wavelengths long at the operating frequency, has the unique property of making the impedance at the feed line input match or look exactly the same as the impedance at the antenna. So if the antenna was presenting a 100 ohm impedance and you had a half wavelength line feeding it, you'd see a 100 ohm impedance, exactly the same thing at the transmitter end. Whatever that impedance is at the far end, the impedance is going to look the same at the other end. But that's really all it is. Okay, so because what will happen with a feed line, this is a whole nother topic we can get into sometime, is if you don't have an impedance match between your feed line length or your feed line itself, and the antenna, the impedance looking into the coax at the transmit side will be a function of the line length. Okay. Remember, the SWR doesn't change, but the impedance does. So it's kind of important to draw the distinction that SWR doesn't imply a given impedance. It implies a whole range of impedances that could result in the same SWR. Okay, and that's why you might see changes sometimes if you add a length or subtract a length, because your SWR indicating device, your meter or something like that, may be sensitive to the actual impedance that it's operating in. And the impedance does change across the line length. It happens to repeat the load impedance at half wavelength intervals. Okay, so that's what's magic about the half wavelength point. The quarter wavelength point, it actually inverts the impedance, or actually inverts the impedance around essentially inverts around the system impedance or the line impedance. What I mean by that is, let's say I've got a feed line that's exactly a quarter wavelength long, and I short the far end of it. It'll look like an open at the feed line end, or the input end. And if I open the other end of it, if I have a quarter wavelength line that's open at the far end, it'll look like a short, okay, at the transmitter end. So that's kind of inverting the impedance. So that's one of the magic pieces of a quarter wavelength line. And there's also some nice things about quarter wavelength lines of different impedances that can be used essentially as matching sections, but that's a whole nother topic as well. So there are a couple of those magic multiples of odd quarter wavelengths and even quarter wavelengths that have to do with the resulting impedances that you get in terms of what happens with the impedance transformation. But it doesn't really do anything to change the SWR that you'd see looking into that line for a given load impedance. So what do we use to measure SWR? A lot of rigs these days have got SWR bridges or SWR meters built in, and they're perfectly fine to use. And most rigs with built-in automatic antenna tuners will use their own internal SWR bridge to adjust the matching network inside the transmitter. And this is really no different than what we did in the older days with the tube equipment, because the output impedance of a tube amplifier or a tube final was not 50 ohms. It was typically a much higher impedance. So there was a matching network there, okay, a pi network there that was used to transfer the most amount of power from that high impedance output from the plate of the tube to the antenna system. Okay, so that there's no harm in using a matching network to make that happen. Most modern transceivers, solid state transceivers, are designed with a 50 ohm output impedance and designed to drive 50 ohm coax. And if you don't have a matched load at the end of the 50 ohm coax, then the input to that feed line is not going to look like 50 ohms. So using a matching network there is just as valid today with modern equipment as it was using a pi network with the tube-based equipment from years ago. So using inline SWR meters is a perfectly valid thing to do. Ones that are built into the instrument or the transceivers. Inline SWR meters are perfectly fine to use. They can be used, and you just want to put them in between the transmitter and the tuner if you're using a tuner. If you've got a transmitter with a built-in tuner, an external SWR meter is not going to help you because you can't put it before the tuner. So you're never going to really see the effect of what that tuner is doing using an inline SWR meter with a built-in tuner inside of a transceiver. Of course, another way to do that is to use an antenna analyzer, like the old trusty MFJ 259B that I've had for, Martin, I don't know how many years, but I still have it, still use it. And since I've gotten some other analyzers too, I've got this little Rig Expert thing here, or maybe even like it was a new little fancy nano VNAs or something like that. These are all different tools that you can use to measure SWR and measure the effectiveness of where your tuner is set. The advantage of all these types of devices is that you don't have to use your transmitter as the RF test source. Each of these will provide their own test signal to send out into the line, measure the reflection coming back, and give you an indication of the SWR. In many cases, some of the newer devices can plot them out versus frequency and things like that, and give you a lot more information. So lots of ways of characterizing it, but I would say is don't pull your hair out to try to get to bring a 1.7 SWR down to 1.3, because it's really a diminishing returns there. You're not going to gain that much more by doing that. So so it was kind of, just a quick little dissertation on a couple of things we can talk about. I don't know if there was any questions that came up in the chat as we kind of chatted about that.
Yeah, that was really interesting. Let's hey Martin, jump in here, Martin. I know Martin is an SWR user. Come on in here, Martin. Hey, Martin.
Okay.
Martin, let me tell you, Martin. Back in 1960s, when we were operating 20-to-1 SWRs, and we didn't even know how to spell SWR, did we?
No, but
That's
we
right.
had a visual indication.
Oh, we didn't even have visual back then, man.
Oh, sure you did.
I
You
don't know.
looked at the plate of the tube. If it was glowing red,
Oh
you
yeah,
were good.
well
if it was
yeah,
blue, you were
that's
way
the
too
case
off.
there. But as Alan mentioned, the older rigs had the Pi networking. We could measure a very wide impedance there, where the new rigs, as he mentioned, they're 50 ohm. And sometimes I think some of the good old days stuff's better, don't you, Martin?
Well, maybe some of it
Maybe.
is.
Yeah, maybe.
But no, you're right though. We had different ways of getting power out, which didn't always work out right. Back then you had two variable capacitors that you had to dip and load and dip,
Yep.
and all you had was a current meter to look at. So we didn't have any idea what the SWR was. We just knew how to dip and load.
Yeah, but that's you tune for maximum antenna line current,
Yeah.
and get the most power out. Tune for maximum smoke, and good to go.
And when we
these
start
meters back then was reading DC input current to the final amplifier.
Right.
We didn't have anything to measure SWR, and the one thing that we did have was a if we were using something like 300 ohm twin lead. That's about all we had back then. But if you were using the TV twin lead, you could use two light bulbs and another piece of twin lead and couple it, and you could tune it where one light bulb would light up and the other one would go out, and that would give you an indication of SWR. And that really was an SWR indicator.
yeah.
Okay.
But
Yeah.
I remember as a kid with a high gain 14 AVQ used vertical. I just put it out there, and I had no idea if it was taking power or not.
Yeah.
Yeah.
Yeah, if somebody
you know,
really is interested in looking and reading up on things, a book I'd highly recommend, out of print I think now, but you can still find, is this book called Reflections by Walter Maxwell. There's really a collection of articles that he's written over the years that really talks about reflections and SWR, and again, dispelling a lot of the myths that you read about. I think it's really well done. And there's also a lot of good information in some of the ARL publications, both the handbook as well as the antenna book. Chapters 22 or 23 and 24, I think, in this antenna book has got a lot of really good information about SWR, and kind of, again, trying to dispel some of the myths. But I think people obsess about it a little bit too much sometimes. Like I said, I know I've actually taken a look at it on my, I've got a 130-foot dipole that kind of zigzags across the backyard and is part vertical and part horizontal, and fed with 450 ohm line into a tuner. And I know on some of the bands I operate on, the SWR on that 450 ohm line is in excess of 30-to-1.
Yeah.
Okay, but I still get out as good, on it with when I adjust the tuner, because I get the impedances matched right, the complex conjugate, make sure that the power gets reflected back to the antenna. The transmitter puts out the full 100 watts, and it's good to go. So
you've got a dipole fed with 450 ohm open wire. Martin and I, we've got some 40 meter extended double ZEPs fed with the 450 ohm line. Now, I'm guessing that neither one of those antennas is 450 ohms at the feed point, but we're feeding with 450 ohm ladder line, right?
Right, exactly right.
So
there's definitely a mismatch. The SWR on that line is probably in excess of 5-to-1, 10-to-1, 20-to-1.
Yeah.
But as long as you adjust the impedance at the feed point of that line, the transmitter sees 50 ohms. The impedance is transformed to give a conjugate match at the input of the feed line, so that all that power makes it down that feed line to the antenna system. So
Now, Brent,
the efficiency of it is really driven by the radiation resistance of the antenna itself.
Brent Glass also asked a question a while ago. Okay, you know, he was describing an antenna tuner that had a 50 ohm, you know, output, coax output, you know, SO239 on
Yep.
it, going to an antenna. And I think he was asking the question, how does that tune it? I mean, it's not. I mean, that's an unbalanced line. I mean, I guess it just does magic, and I don't know.
Yeah, it's just an impedance transformation.
Yeah.
The simplest network is a simple L network. A series shunt component, and they can be capacitors or inductors, and the order of them, depending on whether you're transforming to a higher impedance or a lower impedance, is really what determines that. I run one of the old Pentec 238C tuners, which is an L network tuner. It's a nice low loss tuner that I've in the past used, like some of the other roller inductor pi network tuners. And really just there's a couple of simple formulas that you can use, or go through some Smith chart techniques to figure out what that matching network should be. And since a matching network is actually composed of essentially reactive components, capacitors and inductors, they don't by themselves dissipate power, right? Because anything that's reactive doesn't dissipate power. It's just the resistive losses in those elements are what dissipate the power. So there's a nice homebrew L network.
That's an L network I built yesterday. I took my 1.5 kW tuner out of the line, and I needed something to tune it with. So that's just a very simple L, a capacitor and an inductor. And the thing is, it'll match both high and low impedances. Just if you get the wrong one, just turn it around the other way and connect the transmitter to the other side.
Yeah, there's a nifty little one of the videos I did on L matching networks. There's actually a little, almost like a yin. You're familiar with a yin yang, where it's got these two little kind of squid shaped things that kind of like intersect each other. But what you can actually draw that pattern in the center of a Smith chart, and what that'll show you is what impedance range a given L network configuration will match. And that's one way to kind of look at that is, and then you can look at that and say, okay, my impedance is over here on the Smith chart. I need a shunt L and a series C, or if it's this way, I need a series L and a shunt C, or something like that. But there's ways of figuring that out by looking at the Smith chart. But yeah, so a simple L network can be used to match most impedances. It just may not give you the best Q, whereas a pi network or more elements in the network, you can kind of get a wider Q with that. So.
Yeah. Hey, Martin,
There's a program that comes with the antenna book from the ARRL that's got a transmission line computer program in it, where you can input the antenna impedance, and it'll calculate the L network components, T network, and pi network. It comes with the book.
Yeah. There's mine. There's mine right in there still. I haven't taken it out.
Yeah.
That's one of those things with the CDs and the book. You hate to take it out, but you're going to have to take it out to make it worthwhile.
Yeah.
Well, there's so many of them online now that you can just Google it and.
There's online calculators, and I've even seen some of those online tuner simulators where you can actually kind of turn the virtual knobs and watch the match happen.
So talking about SWR, Martin, I got a question for you. I've always been leery, of course, several years ago. All the solid state stuff that came out over the years as we grew older, it could be damaged really easy with SWR issues, on the antenna. And I was always worried that some of these new high-power amplifiers, solid-state amplifiers, could just be damaged so easy, But the new are the new MOSFETs, or there's some new transistor? I saw a demo of some RF transistors here a while back, and it's on YouTube. The guy was running 1,000 watts, and he actually took a screwdriver and he shorted out the antenna connection, and it didn't hurt the transistors. And he opened it, and it didn't hurt the transistors. Can you talk a little about that?
No, that's true. We're coming out with an amplifier with those type of transistors. But you're right. You can short it, open it, and the transistors won't burn out. The older ones, they had to protect them with SWR sensing circuits that would turn off the transistor, or at least turn the power down.
I think NXP Semiconductor is one that did some of those videos on some very rugged RF power transistors.
Yeah, I've got Martin. I've got an amplifier here. I've got your AL80B. I love the amplifier, but I also have a Alpha 86. If you're familiar with the Alpha products, in the Alpha, they've got a built-in SWR protection, and it's set at 2-to-1. If my SWR ever hits 2-to-1, bam, it turns off, and it won't turn on for 3 minutes. And I guess that's to protect those tubes. The tubes, they got the 3CX800s in them, and that's pretty expensive tube. I think those tubes are anywhere from $500 to $800, $500 or $800 a piece, I think, on the tubes.
They're a lot more expensive now.
Yeah. So I try when I design an antenna. I like using resonant antennas because I can jump around on them and run power. Now, my extended double ZEP. It's not resonant on the frequency, and therefore I'm using your 1.5 kW tuner on it, and it works great. So Martin, I think you even live in a HOA, don't you? Do you have any antennas up?
Well, kind of, yeah.
Well, maybe you can't talk about it because they may be watching, right?
Right.
All right.
I have some few antennas up. The biggest problem that I've had is when they go and mow my yard, they keep cutting my antenna feed line.
Your coax and stuff, yeah. Well,
I was using ladder line.
Oh, are you? Yeah.
Yeah. Feeding through a window.
Oh, man.
One of our club members lives in an HOA, and he's actually got a 6-meter beam in his attic. His attic is that big, and he's got a 6-meter beam and a loop up inside the attic.
I've talked to several people on our 40-meter net that have inside antennas, and they're performing just about as well as an outside antenna, so it can be done.
Oh, yes.
I have a 40-meter vertical that's 17 feet tall. That's right inside my doorway. And I have another 20-meter vertical that's about 3 feet away from me here.
Oh, yeah? All right.
Inside?
Inside.
Oh, my gosh.
Oh, well. Well, so SWRs, I look at all these new people that get on, and everybody nowadays can just about afford an SWR meter, or something like that, an antenna analyzer or something like that. And of course, we didn't have that growing up, Martin, and we didn't really know what SWR was, and we made contacts. But I've learned that if you have a perfect SWR of like a 1-to-1, that don't mean the antenna is actually going to be your best antenna. I mean,
a dummy load may not happen at the resonant point. Might be happening somewhere else, because all resonance means is that the reactive component of the impedance has gone to 0. But that doesn't necessarily correspond to where you're going to have the lowest SWR.
Yeah. So you may have a better antenna at 1.8 than you do at 1.1.
Yeah.
A more effective or efficient antenna, I guess I might say.
Yeah, because resonance isn't always corresponding to lowest SWR, because you might have a resonant antenna that It's resonant, like a dipole, for example, in free space. The ideal feed point impedance is 72 ohms or something like that. It's only when you make it an inverted V where it comes down closer to 50.
Yeah.
Okay,
Yeah.
so even though it's resonant, it's not going to give you a perfect 1-to-1 SWR at resonance, right? And similarly, a dummy load has got a perfect SWR, but it won't radiate worth a darn. So low SWR doesn't always correspond with efficiency and best performing antennas.
Well, here's one for you. Oh, go ahead, Mark.
No, I was going to say, Tom, back then we not only did not have coax or any kind of feed line, one of the antennas that a lot of us only used was just a piece of wire stuck in the back of the transmitter. So, and it's taken full circle now. That's the most popular antenna is an in-fed halfway. Of course, back then it was just a piece of wire that we had.
Some of those
and we were, a random wire, and we were loading and dipping.
Yeah.
Yep.
Yeah, some of those Heath kits had that phono plug in the back.
Ground on it. Do what now?
Some of those Heath kits even had the RCA phono plug in the back.
Oh yeah. Well, the Collins had a phono connector on it.
Well, I built an SWR meter out of the handbook with just small, like a 50 microamp meter, and you build a little pickup loop with just a little short 6-inch piece of coax. You run a little wire under it, and a couple of diodes, and it worked. But back then, and we still have meters today where you have to check the SWR. You have to key up, and you have to adjust the meter on forward. You adjust the meter to maximum right there, and then you go to reverse, and then you read it. You read the SWR. But when we built those, our meters weren't calibrated in SWR. It was just like 0 to 200. And back then you had to use the math to calculate the SWR. And I don't remember what it was now, something like, 1 times the other one divided by 1 plus the other or something. I don't know what it was. But I never did that. I mean, I could...
When I used to, I always like using, even on the tuners, the nice cross needle meters.
Oh, yeah. Yeah.
And people get confused all the time. So how do you read SWR on that, right? Because where they cross, and I always tell them don't worry about it. Just look at your reflected meter and make it go to the minimum reflected power, and you're good to go.
Exactly.
Right.
Now I got a question for you guys. And maybe it's just me, and it's a strange observation, but I've noticed that 15 meters seems to be the hardest to tune and get an SWR reading that's meaningful. Have you seen that, or is it just me?
I think it's something that's going to be antenna specific, antenna and feed line specific. For me, with my antenna, I've got the hardest time with 12 meters. Okay, and I've got a hard time in certain portions of 75 meters with my antenna, and it's just a matter of where you are in terms of the impedance looking into the line, and how far you can match that with your the elements in your tuning network. And that's where sometimes adding or subtracting a little bit of line length might help, because that line length is going to transform the impedance a little bit. Might get closer to the sweet spot of where your antenna can tune to, or your tuner can tune to. And I find that with mine, I can get down and tune the CW portion of 70 meters, 80 meters pretty well. But like proportion of the phone portion of the 80 meter band, I need to feed a feed line to my ladder line length to bring the impedance looking into that into a range that my tuner can handle. It's not changing the SWR. It's just changing the impedance that I'm seeing looking in there. Because
so
again,
let's,
that SWR and impedance, SWR doesn't translate to a fixed impedance. It's a full range of impedances that can give you that same SWR. So by adding feed line length, you're essentially rotating around essentially a constant SWR circle on the Smith chart, and you might find an impedance that is more optimal for your tuner to match compared to being somewhere else on that circle.
So let's talk the 40 meter dipole. This is something that we had back in the olden days, and we were told it'll work on 15 meters. And of course, we had the Pi network and could match quite a bit of different things. So I think I've used the 40 meter back then on 15, and like Martin said, dip and load, and but who knows what impedance
because it comes down to, because the 15 meters is essentially the third harmonic. So if you had something that was a quarter wavelength long on 40, okay, it's 3/4 of a wavelength long.
Would have been a half wave dipole.
Okay. Yeah, but I'm saying each leg, right?
Yeah.
So, but you're just going to, you're making it essentially 3 times longer.
Yeah.
Okay. Remember what we said about, odd quarter wavelengths? A quarter wavelength line is electrically equivalent to a 3/4 wavelength line, okay, in terms of what it does to the impedance. So the same thing happens with antenna elements. Something that's 3 times as long is going to essentially do the same thing as something that's a third as long when you change frequencies that way. So, so for example, if you had a quarter wavelength line that's going to do a certain impedance transformation at a given impedance, but if you increase the frequency by a factor of 3, now that line length is 3/4 long. So it's another odd quarter wavelength multiple. So it's going to do the same impedance transformation, right? So so the same thing with the antenna. The antenna is tuned for 40. Okay, now you go 3 times higher. You're just going to be operating it as a 3/2 wavelength instead of a 1/2 wavelength long antenna.
Yeah.
So
Now,
hey, Tom, basically what you're doing when you go on 15 meters is that the impedance is still low.
Oh, is it?
It's still in pretty good range, so you can match it easily.
Okay.
It really doesn't matter how long your dipole is. If you can get power in, it's going to radiate.
Yeah. Now, one of the things I know is critical, though, is using a dipole and a tuner, using it on a higher band than it's designed for. In other words, you really don't want to use a 40 meter dipole and try to put it on 80 meters with one of your tuners, because
you can generally operate at higher frequencies than the antenna is designed for, but going lower, the antenna is always going to be too short, and that's kind of really tough to compensate for.
Right.
Yep.
And that's pretty much written in a lot of the manuals, Martin, that you guys have with your antenna tuners. That don't try a 40 meter antenna on 80 meters, or don't try an 80 meter on 160 meters. So obviously it has some factors there you don't really want to mess with.
So there was a question in the chat room here by Andy, KD4YSJ. His question is, for those that are not listening in the chat room or looking at the chat, is will your SWR bounce if you have other antennas of the same band that are too near? He said he's got a G5RV, a beam, and a vertical that all cover the same bands connected to a switch and one radio. And sometimes I see a bouncy SWR on corresponding frequencies, sometimes, but not all the time. Well, I guess it really comes down to how much those antennas are going to couple to each other. A G5RV and a vertical are probably not going to couple to each other too much because they're cross-polarized. Okay, I'm assuming that the dipole or the G5RV is somewhat horizontal, okay, and the vertical is vertical. Because they are cross-polarized, there's not going to be a lot of coupling there. You could potentially get some coupling between the G5RV and the beam, depending on their orientation, right? If you're looking at the G5RV is sitting on one side of the beam, and the beam is turned so that it's not pointing at or directly away from the dipole, you're not going to couple much to the ends of the elements. I think it might depend on the orientation, so you get coupling there. If you do get coupling, you certainly could have an influence on the SWR. Depending on if you do that, you might even see that if you measure SWR on your G5RV and rotate the Aggie, right? You might actually see the SWR change if you're getting any coupling between those antennas, depending on how close they are.
Well, let me also say you will get coupling, and I'm going to tell you back in the early days we had tube systems. It wasn't a real issue, but now since everything's solid state, let me tell you something that happened to us here last year. I had a Kenwood TS570 over here with an antenna on it. I wasn't using it; it was turned off, but it had an antenna on it. And then I'm calling the 40-meter net on my other rig, running a kilowatt. So outside, my antenna farm looks like this. I've got 40-meter inverted V. I've got 40-meter delta loop. I've got extended double ZEP. They're all out there within 10, 15 feet of each other. And, after about an hour of net, I started smelling something kind of like the smoke was let out of something. So the next day I opened up my 570 radio, which was turned off, and the power from the transmitter I was on fed back through the other antennas into the turned off 570, and it burned a hole about the size of a nickel in the circuit board, took out a relay, took out a transistor, took out the attenuator circuit, and it did some damage coming back in there. And I think I even
you got
showed
a kilowatt in one antenna that's not that far from another antenna, especially if they're oriented the same way. You can certainly get a lot of coupling.
Yeah, I think I actually on the show one night we took a little light bulb and we put it on the feed line from the other antenna and we keyed up on the other one. You could see the bulb light up. So we knew we had power coming back. So hey, guys, you don't have to be on the same band. You don't even have to be turned on. The solid state stuff, you will destroy it if you get too much of a signal back into it. So always be careful on that.
Yeah, so it all comes down to orientation of those antennas. If you got them, you said within 10 or 15 feet of each other, and essentially if they're in the same polarization, they're not like crossing each other. You certainly get a lot of coupling that way, and especially if you've got a loop that's going to kind of radiate all over the place. So that will certainly affect that too. So. And a kilowatt that's transmitting one antenna into another one that's 20 or 30 feet away, you're certainly going to get a significant amount of coupling there.
Yeah.
Now, here we run 3 stations out of one shack, and as a general rule, I always ground any unused antennas. They don't float them to anything coming back into the rigs.
Yeah.
We got to give him a microphone. Well, we heard you.
We
heard you. We heard you, Dwayne. You were just low.
Yeah.
Oh.
Well, but Dwayne, you have the expert station set up with all your switches and grounds and all that. I mean, some of us that are newbies that only been in 50-something years, we don't have all that yet, man.
Well, when I first got started in ham radio, I had a piece of copper that was a 2-inch wide piece of copper that's 1/4 inch thick, and I drilled holes in that, and I put I don't know what she's doing, but
It was attacking Tom.
I know what she's doing.
but I put in a whole bunch of the I robbed a whole bunch of CB radios and took the SO239 out of the back of it.
Yeah.
And soldered them to that bar. And so any radio or any antenna I wasn't actively using, I had screwed right into that bar. So that was the way I did it in the old days.
Yeah.
Well,
Brett mentioned in the chat that he's crashed computers in an adjacent room when transmitting only 100 watts. And in my previous house, I had a situation where just running 100 watts, if I ran 100 watts in the CW portion of 40 meters, I'd pop the GFI breaker in the bathroom, just couple enough into my power grid in my house at that frequency. So
when we moved in here, the people that lived here before hired an electrician to put in the arc fault breakers.
Yeah.
And the very first instant I keyed that up, we lost all the power in all the bedrooms.
Oh man!
And, since then, those have been modified.
Well, and hey, just a few years back, my previous house, we had an alarm system, and the antenna ran right over the roof with the alarm system wiring in the attic, and I keyed up and it set the fire alarm off, not the entry, but the fire alarm. Well, there's no way to disable the fire alarm. It's on all the time. You can disable the entry, but anyway, the fire department came. I got to meet the fire department. I tried to stop them, but they said they were on their way. They had to come. So it's a crazy rule. Martin, you ever done anything crazy? Martin, you ever done anything crazy there? I mean, you used to work in your shack upstairs in that little grocery store in the attic, and it didn't even have a floor in it. Did you ever fall through the floor, through the attic?
No, I was real careful. We used to have, what do you call those things at the end where you would let air in or put a big fan there.
A vent, some type vent,
Louver
vent.
Yeah, but this is huge. You put huge fan in there. Anyway, that's and it was all the way at the other end, and I used to run TV twin lead out through those vents.
Louvers. They're called louvers.
Yeah. Climb up in the attic. Used a plank for a table.
Good old days.
Old days.
So did you run your twin lead through the fan? Did it ever cut it, or did you go around it?
No, we didn't have a fan.
Oh, you didn't have a fan. Okay.
Did that? Yeah, it was hot. That was back in the days with no air conditioning.
Yeah. Okay.
That was 70. Was it 70 years ago? 60 years ago.
Yeah.
60 years.
Now, so hey, describe me your station. Now, was it sitting on like a 4x8 sheet of plywood? How did you set that up here in that attic with no floor?
Well, I think it was a shelf that was in the store.
Oh man!
And I used some plates to hold it up. I mean, it wasn't exactly a sawhorse, but kind of like that.
Okay.
And the transmitter was a homemade transmitter using a 25-cent tube, a 1625 from Bernstein Appleby.
All right, man.
The schematic was a copy of the Heathkit DX35, and the power supply was built on that chassis from a TV set, and it didn't have enough voltage. So, and it had plug-in coils, and the power input was 22 watts. And the first receiver I had was a regenerative receiver. And I could never make a contact with that receiver. You would tune in a signal, and you move your hand away from the knob, and the signal would disappear.
Well, you got to tune with your left hand and send with your right hand.
Yeah.
Just about.
Yeah.
Oh, man. So.
Yeah. Let's see. 60 years ago.
All
and
right.
then, of course, you had to chase whoever you were contacting up and down the band as you all drifted.
That's true. You're right.
Well, Martin, did you ever get a official observer letter in the mail or a postcard?
I can't. I used to be worried about that all the time, but I can't remember if I ever got one. I might have. I would be surprised if I did, but I don't remember.
I think I got one. I actually got a letter from the FCC.
Oh, man.
I got a letter. I got a
you.
letter from the FCC. I think I was something like 12 cycles out of the novice band, man. Oh man! And back then, I took it seriously. Back then we took the FCC serious.
Absolutely.
Absolutely, yeah.
Because I mean, to get your license back in, you got to go down to the government building, and the lady that wears that the drill instructor hat, that yells at you, and all that. I mean, you were put through the mill, man, to get your license. But yeah, I got a letter. I got a letter, and I had to send it back in triplicate. I don't know why they need triplicate.
when you renewed your license, you had to bring your logbook and prove that you'd operated a certain number of hours the
Well,
previous year.
I think you had to at least say you did. I don't know that you had to show it. But, hey, that brings up another thing. I don't know if people watching know, but the FCC is proposing charging a fee now for new licenses, $50, renewals, $50. So I don't know. I guess that's still not too bad. That's $5 a year. But, to some young people,
That's pretty hefty up front. though.
Martin may have not been able to afford $50 back when he was
Oh, I could.
got his license.
Yeah.
My
Well,
parents. Yeah.
The reason they quit charging was because it cost more to charge than what they got.
Well, but
They process the money, yeah.
wasn't it a low amount? I don't remember what it was. Wasn't it like $10 or something? It wasn't much.
Yeah, something like that.
But now they're wanting to go up to $50. They're going to get their money's worth with $50.
Yeah.
I know it's still open for public comment. So your local section manager, if you belong to the ARL, probably sent out something, to everybody that I know mine did here, with links to where and contribute to the public comments.
Yeah, ARRL sent that out in their newsletter today.
Yeah.
That they're going to comment, and they've invited all the hams to comment as well.
Yep.
That's $50 for anything that you do.
I think if you make,
copy your license.
I think there was a couple things, like maybe an address change. It wasn't going to cost that much, but I think a renewal or a new license, they're proposing that.
Yeah, I think even if you wanted a paper copy of your license, it was going to be $50.
Yeah.
It was going to be an extra $50 for the paper copy.
Okay.
Yeah, but you can print the copy off right now, and it's just like the original. You can print it off on the web now. They may take that away. I don't know.
Yeah, like I said, it's not passed yet, but that's what they propose. So we'll see what happens.
Well, okay. Well, while we're talking about Martin, did you ever operate without a license?
No.
Did your license ever expire and you keep operating?
No.
I was up
I've done that.
Let me tell you, I was up at Dayton one year, 25 years ago. We were all at dinner looking at our license. And I pulled mine out, and mine had expired 3 months earlier. So I had to renew it. Good thing nobody heard me.
Yeah, I think I've always gotten the letter, from ARRL or somebody like that to kind of remind me, when it's time.
Yeah, but we were terrified of getting a letter or a visit from the FCC. No, we weren't going to do anything like that.
Well,
you're right.
it was always $10,000 or 10 years in prison, right?
And we were convinced they were right outside our window.
That's right. That's right, man. Yeah. Oh,
You're right. You stayed away from the band edges.
Yes, sir.
Oh, man. Well, a lot has changed over those years, I guess for the better. Martin, if we had had these radios that we have today back 60 years, 50 years ago, man, it would have been great, wouldn't it? But we still had a lot of fun.
Yeah, I mean, as kids, I don't know if we could figure out how to operate.
Probably not. Well, I don't know. Kids usually operate stuff a lot better than the older people, but
I think half the fun was getting that old stuff to work.
I don't. Well,
building your own Heath kit at the time for a 15-year-old, that was just awesome to me.
Well, it was pretty simple, actually. Like that transmitter Martin built. I bet that transmitter probably didn't have more than 25 parts in it. So look at there, man.
Yeah, it was pretty simple.
Pretty simple. Maybe 20, 25 parts. Not much to go wrong. And
I don't know.
Yeah.
My second one was an HW101, and let me tell you what, there was more than one tube inside that thing.
I built the HW100 probably a year or two before that, and there were a lot of parts in there.
Yeah.
And Martin, I saw on your shelf here in your office, you got a Knight T150. I built a Knight T150. There was a lot of parts in it.
Yeah, That was a real transmitter.
Yeah.
Built-in VFO, AM modulator.
It was 80 through 6.
Yeah.
Yeah. And I actually put a plate modulation on it. Man, that thing worked good.
You know, I didn't have a whole lot of options to get on 6 meters back then. You know, now that I can get on it, it's actually one of my favorite bands when it opens up. It's a blast.
Yeah. It's
You have to wait too long for band openings.
yeah.
Hopefully the cycle coming back up, you won't have to wait too long anymore.
Yeah. How's the dead zone on 80 meters?
The dead zone?
Isn't it the dead zone? I mean, during the night, sometimes you can't hardly talk to anybody, can you? Because of the dead zone.
I don't really listen on 80 that much. I've even found that on 40, the dead zone sometimes, man. I mean,
Yeah.
Yeah, I think hopefully, like I said, as we come out of the doldrums of the in between the cycles and sunspot cycles picking up here, I think we'll do a lot better. But I mean, for you know, I guess 75, 80 just gets more and more local, you know, at night for me. But you know, it's I spend probably more of my time on 40 anyway. So.
And I'm a 20 guy. I love it when 20's open late until the night.
Yeah.
Y'all been operating some FT8?
Not me. I've been writing a book.
Yeah.
I tried FT8.
I don't have a computer anywhere near my radio, so I'm purely CW and single sideband.
I tried it, Martin, this past year. I did a little FT8. I'm not a digital guy. That's probably the first digital I did in 30 years. But I made a few contacts with it. It was kind of fun, you know. I mean, to do. But I mean, you know,
Why are there so many people on FT8? I mean,
well, it's so easy to make a contact. You know, I mean, it's you know, just a few watts. You'll make a contact just about anywhere around the world with it. You know.
Yeah, and it's all automatic, right? You automatically recognize things. You get the automatic exchanges back and forth. That coupled with the fact that you know, how many times are you tuning around the band if someone calls CW and they're kind of in the noise, you don't answer them.
Yeah.
Here, if FT8 can hear it, it'll answer it, right? You can just answer it. It doesn't really matter. So you know, it's just I'm a bit more of a rag viewer, I guess. So I like to you know, so I have kind of steered. I just haven't found an interest in it myself. But like I said, I don't have a computer anywhere near my radios at this point yet in my shack.
you know, I'm getting paper QSL cards for FT8 contacts.
Oh, really?
That you haven't made?
Yeah.
That you haven't made, is that right?
No, I made them.
Oh, you did make them. Okay.
Yeah. But you're right, though. You can run, I never run much more than 1 or 2 watts.
Yeah.
Well, there's I don't know if the distance record holds, but I've saw some YouTubes where a guy actually ran a coax up to a light bulb, set it in his window, and made a contact, you know, 1,500 miles away on a fluorescent light bulb for the antenna.
Yeah, there's a group that actually runs contests making contacts with light bulbs, antennas.
Huh.
Yeah. Well, Martin, maybe we ought to try that some night.
Well,
let's don't
you know, if you can imagine making a contact and you can't even hear the signal.
Yeah.
That's like you know, I guess Richard was talking about. He's got an article on Whisper, and I experimented with that a couple years ago. I was on a little Whisper transmitters. I was running it on 20 meters through my tuner at 50 milliwatts, and it's one of those things. It's just a beacon, right? You're not sitting there trying to make contact. Let it run. It's kind of a propagation reporter, right? Weak signal propagation reporter is what Whisper stands for. And I let it run a couple of days, and I went and checked my logs for it, you know, to see what was heard from all these listeners that are out there and sniffers that are out there. And that 50 milliwatt signal was heard from New Jersey. It was heard in Madagascar. It was heard on the South Pole. It was heard in, you know, South America. It was heard in Russia. and then of course all over the U.S. But I mean, I think the Madagascar and Australia contacts and then the South Pole contacts were the furthest. And I forget what
Wow.
out the miles per watt. It was some ridiculous number, 50 watts at 12,000 miles or something like that. It's pretty crazy.
Did you say 50 or 15?
Oh,
15?
50 milliwatts.
50 milliwatts.
50 milliwatts, so 0.5
Okay.
watts.
Okay. Wow.
Well, these
That's
little
pretty
balloons,
incredible.
well, these little balloons are like 10 milliwatts, and look at the whisper reception we're getting off of those.
Oh yeah.
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 Well, the antenna's
Like I
up
said,
a
you
little
got the software that can actually hear below the noise floor because they're essentially setting receive bandwidths down, sub-hertz receive bandwidth, so it drops the noise floor down to the point where you can't hear it because you've got a wider bandwidth in your ear than the software
Yeah.
does.
Did you see the new mode for the 630
30?
meter band and 2200 meter band? It's like
Listen.
the transmission is like 30 hours.
Holy
my
cow!
gosh.
Is that right? Oh, man.
I don't have that much patience.
30. Oh, man. I was just going to bring up the 630 band. I was wanting to try to operate it, but I don't know. If you have to transmit 30 hours to make a contact, then I guess it's 30 hours back.
Well, that was the longest mode. There's two new modes that Joe Taylor just released.
Okay.
Well, I think what I'm going to try next, I need to get my satellite stuff turned back on over there, but I think what I'm going to try next is some EME, some moon bounce. I won't be able to do it running 100
that's what
watts.
the JT65 was designed
Yeah,
for.
I won't be able to do a 100-watt sideband. That's just pretty much impossible to do it voice or CW at that power. But with JT65, it's very possible to actually make a contact with EME, and I think I'm going to try that sometime.
Yeah.
And
Did I ever tell you about
play with that?
what we did with EME here in New Jersey when we recreated the Project Diana experiment? Did I talk about that here?
Now, what was the project?
So it was an anniversary of Project Diana.
Yeah, we had that on a show. We had a whole show about that.
Okay. I remember if we had talked about what we had done when we celebrated the 75th anniversary of that.
Okay, well, you
was
weren't
that?
you weren't
Was that
there,
the-
but somebody came in and we did a show on that on the anniversary for Project Diane.
Okay.
But that was
What
yeah.
was that? Was that the first contact?
No,
First
well,
EME?
Yeah, so the Project Diana was run by the U.S. Army Signal Corps in 1946, I think.
Somewhere
And
here.
it was the first time that the claim is that it was the first time that a radio signal was bounced off the moon. Of course, there are other folks in the world that say that, oh, well, the Russians did this before that or whatever. I think the accurate thing to say is the first time the U.S. bounced a signal off the moon. And the claim is that it really kind of helped pave the way for human space flight because up until that point, they didn't know if if a radio signal could penetrate the atmosphere and come back. But it was actually done at the U.S. Army Signal Corps at part of Fort Monmouth in New Jersey at an area called Evans area or Camp Evans. And it was done at 115 megahertz with like one of these big spring style radar antennas. And the radio club I belonged to at the time, our club location was in the same building where that transmitter existed. The stanchions from that old tower were just outside the building, so that old antenna wasn't there anymore. But on the same property down at Camp Evans is a 18-meter parabolic dish that was part of the Tyros satellite, which was the first weather satellite. So we, both our club at the time and Princeton University collaborated in refurbishing that 18-meter dish because Princeton wanted to use it for pulsar research. So they had motivation. So we decided, well, 75th anniversary of Project Diana was coming up. So we put together an event, a special event, where we were going to use the 18-meter dish running at 1296 with 200 watts of speed power.
Wow.
So 18 meters on a 18-meter dish at 1296,
Man,
47 dB of gain.
good gosh.
So 47 dB of gain with about a 1 or 1.2 degree beam width. So we had to actively track and follow the moon. But so we, exactly to the date and time of the initial transmission of Project Diana, we sent the club call sign up to the moon and bounced it back. And then we just ran all afternoon, ran some EME contacts, but with effectively about 7 million watts of effective radiated power to the moon.
Wow.
So Alan, I got to
we're getting S9 signal reports.
Yeah, I got to ask.
Wow.
I've got
Unbelievable.
I've got to ask this, Alan. You weren't afraid you might blow the moon up?
No, we had it set to stun.
Well, yeah, probably people don't know what I'm talking about. If you watch The Big Bang Theory, you'll probably understand what we were talking about.
Yep.
Yeah.
Well, they did it on Space 1999.
Had it set on stun. That was the line right there.
That was the line, yes.
Yeah.
That's unbelievable. S9 signal bounced back.
On single sideband, no less.
Wow.
Yeah.
Yeah, because it's a 2.5 second delay, so you could actually we'd send the call sign of the radio of the club station unkey, and you heard your signal bouncing back off the moon at like S9 plus.
Wow.
Unbelievable.
Bandwidth.
Now,
2.5 seconds later is pretty incredible.
I don't have any experience with the JT9, but I think it or one of those has an echo mode. Are you familiar with that?
I'm not familiar with that mode, no.
It has an echo function or something where you can actually watch for, send a signal, and watch for it to come back. With that delay. So we're gonna have to experiment with that. All right. So let's see. Just an update on the balloons. We may try to get a balloon off in the next. Maybe by this coming weekend, I don't know. It depends on how the weather is. We haven't been in too much of a hurry. Martin, our last balloon went around the world 3 times in 72 days, so I thought that was pretty good. And
yeah,
our goal
what kind of balloon was it?
It was just a small Pico balloon with a little tracker under it.
Wow.
And our goal was just to get around once, and we went 3 times. So we're going to try one more time. Maybe we can beat that record. Get it, and Bill Brown down there in Huntsville helps us, and I think he's in the chat room tonight. I saw him earlier. He just launched helped a school down in Australia launch a balloon about an hour ago down in Australia. So this hobby is, being seen by a lot of school kids around the world now, and having a lot of fun with it. So we may try to launch it on this weekend. It just depends. And that's about it. Guys, we're running late tonight. I guess we'll probably go ahead and close the show. Glenn, we didn't get to any specific subject you had. Did you have anything you wanted to talk about?
Not really tonight. I mean, this is the notes for the next chapter of the book.
Okay.
And just trudging right along there. And next week, if you want, I can have some pictures of the projects.
Okay, let's do that next week. We'll do some of your projects.
Going through this, I'm uploading all my pictures to ARRL and everything because we're turning this thing in as we go.
Yeah. Okay. All right, guys. Well, look. Hey, thanks everybody for being with us tonight, and we're going to say 73 to everybody out there on the in the chat room, and we're going to get this thing straightened out. We had 2 chat rooms going tonight. YouTube chat room was on, which is supposed to be turned off. I've always had it turned off, but they turned it back on. And in our chat room, and then I've got to fix the embedded video deal. So something changed. It's 10:03. Good night to everybody. If you're listening out there on WBCQ on 6160, send us an email to tom@w5kub.com. tom@w5kub.com. I'd like to hear from you. Where are you? Where are you hearing it? And you can always join our show every Tuesday night on this frequency of 6160 kilohertz. Or if you have internet, you can go to w5kub.com and join the live show.
Hey,
Good night
Tom?
to everybody. You have something, Glenn?
Yeah. Don't forget, next week is the election, so there's probably not going to be a show next week.
Good point. We will not have a show next Tuesday night. That is the election night. We won't have a show. So we'll plan a show for the following week. So everybody get out and vote, and we'll see you later.
All right.